Welcome back, friends. In this lecture, we are going to discuss about look-ahead LR parser. So we are going to take the same production rule what we performed for SLR and CLR. So LR parser is the combination of SLR parser and CLR parser. So here I haven't mentioned the performance of the how to derive the closure items. Instead of that, I have mentioned what are all the closure items we obtained from CLR parser table. So the SLR parser table is less powerful and CLR parser table is more powerful. But comparing to SLR, CLR has more number of states. So what we are going to do in LALR parser is we are going to merge the concept of SLR and CLR here, and we will reduce the number of states produced by CLR parser. So we will see how to perform those things. So these are the operations we did for CLR parser. The same thing has to be performed up to computing the closure items, up to computing the number of states. So these are the number of states we have identified in CLR parser that I have mentioned here. I0, I1, I2, I3, I4, I5, I6, I7, I8, and I9. Totally 10 states. From I0 to I9, it is 10 states. So what we are going to do is we are going to check what are all the states are equal. So you see here I3 and I6 is equal except their lookaheads. So now we are going to combine I3 and I6 like this. I3 and I6 can be combined, and the production rule can be mentioned like this. Yes, C tends to C terminal C dot C, and the lookahead of I3 is C slash D, and the lookahead of I6 is dollar. That has been mentioned as C slash D slash dollar. So like this, we can combine the production of I3 and I6 because the production rules of I3 and I6 are same. Similar to I3 and I6, you can see here I4 and I7 are having the same production rule. Again, combine I4 and I7. So C tends to D dot. So C slash D slash dollar. Again, I8 to I9, I8 and I9. Combine I8 and I9. You see here, C tends to CC dot or C slash D slash dollar. So like this, we can combine the states which are all equal. After that, uh, design the parsing table, LALR parsing table in this fashion. After combining, you can see here before in CLR parser we are having 10 states. Now the states has been reduced to 7. You see here how I have combined the states. I0 0 1 2. So these two 0 1 2 and fifth state. So these four states are unique states. So it doesn't have any match with some other state. So it stays as a unique state 0, 1, 2, and 5. The remaining states 3 and 6 are combined, 4 and 7 are combined, and 8 and 9 are combined. So totally it is 7 states 0, 1, 2, 3, 6, 4, 7, 8, 9, and 5. Totally there are 7 states. Now you see here I0. So we have so previously in the CLR parser we have that I0 comma C, the 0 comma C is the transition, the state I0 to the transition C, we will be having S3. So here, where and all if you are seeing 3, you have to combine with 6. And where and all you are seeing 4, it should be combined with 7. And where and all you are seeing 8, it should be combined with 9. Okay, so like this we have framed the LALR parser. This is similar to CLR parser, but only difference is we have combined the states. Okay, so I2 and IC, sorry, I2 comma C, we might be having S3. So if it is S3 means you have to include 6, so it will become S36. From I3 to C, if you are getting I6 means, so we will be in CLR table, we might be mentioned that S6. So now if you are having 6, you have to combine with 3. So it is mentioned as S36. So like this, the parsing table can be constructed for the LALR parser. Now we will see how to parse the input string, the terminal CD, with the help of the LALR parsing table. The procedure is same. Again, we are starting with the three components: stack, input, buffer, and action. You see here the dollar is the initial thing mentioned in the stack, and in the input buffer the dollar is mentioned to indicate the end of the input string. So the initial state is 0. Now you see here 0 and C. The 0, while the transition performed for 0 and C, you will be getting S36. The meaning is shift S36. So we have to perform the shift operation. So this C will be shifted to the stack 0 C, and the number 36 will be mentioned here. The same procedure what we have followed for the shift reduce parser. So now 3 6 and 3 6 is checking for the transition D. 3 6 and D, it is S47, that is shift S47. So the D will be shifted here and the 47 will be mentioned here. So D47. So CD dollar. So now you see here 47 C and 47 and C. You see here R3. You have to reduce this D with the third production rule C. So how we can mention is $0 S36. Now this D will be reduced. This D will be reduced with the non-terminal C, and you have to perform the transition for the 3 6 and C. So 3 6 and C is 89. 3 6 and C is 89. So 89 and C, 89 and C, you see here 89 and C, again reduce operation. So reduce R2, second production rule, non-terminal C tends to terminal C and non-terminal C. So what you can see here, both the things, this terminal C and non-terminal C has been reduced with the non-terminal C $0, non-terminal C 2. So how this 2 has been mentioned? 0 and C. You see here 0 and C, 0 and non-terminal C is 2. So 2, then 2 and terminal C, that is 2 and terminal C, that is shift S36. So S36 means we have to perform the shift operation. So this C will be shifted here and 36 will be mentioned here. Then 36D, 36 and D, that is shift S47. So now what we are going to do is this D will be transferred to this D will be mentioned in the top of the stack element, and 47 will be mentioned here. So now again perform the transition for 47 and dollar. 47 and dollar is reduce R3. So reduce R3 means third production rule. Again, this D will be reduced with the non-terminal C. Then you have to perform the transition with 36 and C, 3 6 and C. So 3 6 and non-terminal C is 89. That has been mentioned here. Now 89 and dollar. So 89 and dollar means you have to perform the reduce operation with the second production rule. Second production is C tends to terminal C and non-terminal C. You see here these two things will be reduced. This terminal C and thus non-terminal C will be reduced. So remaining you will be having $0 C2, $0 non-terminal C2, and these two things will be reduced with non-terminal C and 2 and C. 2 and C is 5. 2 and C is 5. Okay. So now 5 and dollar. 5 and dollar is reduce. We have to perform R1 operation, reduce R1. So reduce R1 means 5 and dollar is reduce R1. So what we will be mentioning is $0. So reduce R1 means first production rule. So S tends to non-terminal C, non-terminal C. So 0, yes. Okay. And what is the number 0 and yes? What is the number 0 and yes? It will be 1. Now 1 and dollar is accept. Okay. So this is how we can parse the input string by using the LALR parser. I hope you have understood the difference between the SLR parser, CLR parser, and LALR parser. So SLR parser is a simple LR parser. So and CLR parser is a canonical LR parser. LALR parser is a look-ahead LR parser. Among these three parsers, CLR parser is more powerful, but it contains more states comparing to SLR and LALR. So actually, in order to reduce the number of states, LALR parser has been performed. LALR parser uses the concept of SLR and CLR, and it measures the concept of SLR and CLR in order to reduce the number of states. Okay. So this is what the bottom up parsing, how the bottom up parsing is using the shift reduce parser for the parsing the input string. Thank you.